Hello, this is question 8 on your November 2020 paper 2 from AQA. You have a curve with parametric equations, so x is t squared and y is 2t, and these are the limits for t. And this is the graph. So find a Cartesian equation of the curve in the form y squared equals fx. So we are going to eliminate t between these two equations. It's like solving, remember, simultaneous equations. So I have x is t squared, y is 2t. So in the easiest one, I'm going to make t the subject, so t is going to be y divided by 2, and then I'm going to substitute in the other one. So I have that x is t squared, and they asked me to write in the form y squared, so I'm going to just make y squared the subject. So this means that y squared is 4x, yeah, and that's the expression that we need to find. Then for b, it says the point A, this one, lies on the curve when t is a, so the parameter is a. The tangent to the curve at a, this one is at an angle theta with the horizontal. Point B has coordinates 1, 0, and the line AB is at an angle phi to the x-axis, this one. By considering the gradient of the curve, show that tan theta is 1 over a. The gradient of the curve. So we are going to find the gradient at this point and then see if we can find that expression. So the gradient at the point is given by the derivative. Sorry, let me have one page. It's going to be dy by dx, and when we have parametric equations, we are going to do dy by dt divided by dx by dt. Dy by dt is the derivative of this one, so it's 2, and then dx by dt is 2t, so I have 2 divided by 2t. That's my derivative, 2 divided by 2t, which is 1 over t. This derivative, when t is a, so at a, the gradient, so we can write y prime, or the gradient is going to be 1 over a. That's the gradient of the line here. But we know that the gradient is the tan of the angle, yeah? So if you have, you need to find the gradient of this line. Remember, we do always change in y. Remember, y2 minus y1, so increase in y divided by the increase in x. Yeah, that's the gradient of the line. The gradient was difference in x, difference in difference in y divided by difference in x, and writing this triangle, which means increase. But this is precisely opposite divided by adjacent, so is angle of this is the tan of this angle, right? So the gradient, even if you haven't realized, is the tan of the angle. Yeah. So this is going to be tan of this angle here, theta. That's what we needed to prove. Tan theta. We can clean this. Next part, so this is BI, it says find tan phi in terms of A. So we have 2 points, and tan of this angle, if we think about this triangle, so we can consider this triangle here, right angle, this one, this triangle, tan of this angle is going to be opposite divided by adjacent. Opposite is the y of the point A. That was the y of the point A, it was 2a, yeah? So the point A is when t is a, which means that x is t squared, so a squared, and 2a. So this side is 2a, and this length is going to be the coordinate of this point, the x coordinate of this point, which is a squared, minus b, which is 1. So this bit here is a squared minus 1. So the tangent of phi is going to be 2a divided by a squared minus 1. tan phi is 2a divided by a squared minus 1. Then show that tan 2 theta is equal to tan phi. So tan 2 theta, if we use the double angle formula, I'm going to remind you that tan 2 theta is 2 tan theta divided by 1 minus tan squared. Yeah, that's the double angle formula for tan. Tan theta is 1 over a. We found it before, so we are just going to substitute in terms of a. So this is 2 times 1 over a divided by 1 minus 1 over a squared. And we are going to work with this expression, and we are going to see if this is equal to tan phi, which is this value here. So in the numerator I have 2 divided by a, and in the denominator I have, when I square this, I have 1 over a squared multiplied by 1, so I have a squared minus 1 divided by a squared. I can cancel this a with the squared, and I have in the numerator 2a, and in the denominator I have a squared minus 1. Yeah, and just dividing these two fractions, this fraction divided by this fraction, so 2 divided by a divided by a squared minus 1 divided by a squared. When I multiply, I divide the fractions, I multiply this by this goes to the top, this by this goes to the bottom, and I cancel the a's. Yeah, and just doing that, just dividing the two fractions. And this is tan phi. That's what we needed to prove. Yeah, from here. And that's all with this. That's all with this question.